Okay, so you saw a bunch of stuff here. This we're going to go through the next time. I'm going to show all this in a microscope and underneath here and all that stuff. Because I think I understand most of this based on Mudfossil Research. And all these little bumps, what are they doing sticking out of here? This green stuff. Why did it turn green? Why did this get all shiny looking, flaky looking like that? Because this is all one big piece. This is not something that's glued on there or splashed on there. Alright, and what do we got up there, that little bugger? What about this? How did that get made? Selenite. I have a bunch of selenite here, and everything's amazing. Once you understand it, it's just incredible. Now, so what am I going to say? I have a meteorite here. This is a little tiny iron meteorite, and it's a lung. And I'll show you in the microscope. It is a lung, and it's magnetic. Now we're going to take a look at that in a microscope. But before I do that, I want to show you something. This is a iron meteorite, and here's all these different crystal patterns. Those are the flocculation. That's where the crystals have found each other, and they get together and they flocculate. Now, what do we got here? This is something black and something red. Well, and then there's this wrinkly little area over here. What's going on with that? It looks kind of red, and that is brilliant red, and that is black as black gets. And this side here has a lot of black to it too. But this side here has a lot of red to it. So what does that mean? Well, let's look at it close up. Here it is close. You see how red that is? That is pretty red, my friends. Well, what does that mean? Why would that glob of red doing right in the middle of an iron meteorite? And what's the red doing here? That's red too. Look at it closely. You can see the red quite easy. Now, what is on the other side of this? I am going to say this is a heart. And on the other side is the black. That is the way hearts work. One side has the red, one side has the black. And at one time, these were different valves. And the whole thing balled up into a big ball of iron, gooey iron, and everybody flocculated together and found comfort with their neighbors. So, this side down here is the black. Not hard to see. Black, black. That's the side that is the used blood, the vein blood. Red, red. That's the side that is not. Now, is it something like this? Something like that? I don't know. But it's definitely got the red and black, and it's definitely got the flocculation of metals. These are all metals. That's why it smelts off. All the stuff that's lower than metals burns off. And like this is a lung. I'm going to show you this lung because you see all that fabric on the outside of it, all those little white flaky things? That burns off if this came through space. You'd still have all your blood and your metals inside, and iron and all that stuff. But all of this would burn off just like that did. This did not come through space. This was in the Great Flood. That's why it's flat there, and there's where the heart was. And that is actually, I can't remember what they call it, arch of the aorta or something like that. But that's where the heart sat, right back there. And there's a tube that runs right down into the heart. This is a left human lung, and it's human. It's been DNA tested human. I have everything that I make a claim on, I support with 100% solid evidence, rock solid as a matter of fact. Now we're going to look at this lung in a microscope. I'm going to show you, I can get blood out of this. And that could be tested. And I have been trying to get somebody to test it. Nobody will do it. I'll show you how easy it is to get blood out of this. And, you know, you obviously have to do stuff carefully. I'm not going to take the blood today. But you just take it out, and you put it in this tube of fluids, and you send it off, and they look at it. We're not talking rocket science here. We're talking get in deep enough to where you got uncontaminated blood. You get it out of there, put it on that swab, out it goes, they test it for the DNA. Where did it come from? We know it's a lung. I'll show you, there's no question, 100% certainty. Zero chance that I am wrong. None, zero. Below zero. This is 100% certainty. This is a lung, and 100% certainty it came through space, and 100% certainty that all the alveoli in here blew out from the heating of the little chambers that are in here called alveoli. They're little balls. They popped. I'm going to show you this in a microscope, and I can show you how simple it is to get DNA out of here. There's just still raw blood in here. And the reason is things turn to iron when they come through the atmosphere is they heat up hot. And to smelt, this is called smelting, to create iron from raw materials, you got to get rid of all other stuff, and they burn off at certain temperatures. Everything burns off at a certain temperature, and it goes up the periodic chart. Basically, all these things go away until you get up into your irons and your metals and all that stuff. And that's what all these different things are. You got in your blood, there's virtually every metal there is. They just did a study of 26 different metals, and that's just, and they didn't even check iron. They did 26 different metals to see what is in the blood, what's being affected, and levels and so forth. But they selected 26 different metals to test. So your blood is just virtually nothing but metals. And serum, it carries it around, and they pick up charges. That's what these do. They're transition metal elements, and they have all these what they call ligands. I don't want to get too deep because it confuses people, but they're little grabbers that grab onto little molecules. They carry them through your body, and somebody else says, hey, I'd like to have some of that, and they pop it off, and by the time they're done, they get pulled back the vein and get some more. You see this? This is not my picture. Somebody's talking about chondrules, all these little balls. That is skin. That's literally skin. And that's the artery, and this is the vein. They're called the oldest solid material in the solar system. How did they come up with that? I know exactly what all these little balls are the same balls that are in skin. There's nothing but biology. This is, I think they call this a stony meteorite, a chondrule meteorite, something like that. All right, I'm going to show you a lung that came through space, a little one, but you're going to see iron banding. The red pushes the black away. They don't like each other. They have a polarity that says, stay away from me, I'll stay away from you. This is called iron banding. Now, this is exceptional, but I have iron banding here. It's all over the place. And what it does, as I'm going to show you in this meteorite, you're going to see black and you're going to see red. They don't mix. They don't mix together and make sort of half and half. They stay on their own side of the road here. And this is going to be the iron meteorite we're going to look at. I'm going to show you this outer edge here. This is the same as this. All right? They're both meteorites. All right, well, this is a meteorite, but they're both lungs. Now, we're going to see if this cooked off, what you would see is a lot of black, which is the cooked blood turning into iron, and then the white would be burnt off and then go away, because that's what smelting is. You get rid of all this white gooey stuff that doesn't mean much, and you get down to where the metal is. We're down to the metal, but not everywhere. So I'm going to be able to show you the white stuff on top of here, but just a little here and there, because it's in a process of turning into iron. That's what smelting is. You get rid of all the cheap stuff, and you get to where the iron and the metals are, and then they flocculate together when they turn into a ball. This didn't quite hit that amount of melt. So it kept its natural form, and it kept a lot of blood in here. I'm going to show you this. I know there's no question whatsoever we get blood out of here. I'm going to actually show you how I would extract it right now. And I did show you, I think I showed you all the different DNAs. It was simple. You just take a little Q-tip and you put it in the stuff and they test it. So let's look at it in a microscope and then we'll go from there. Okay, there's all kinds of holes all over this meteorite. Now this is dry. When I make it wet, you're going to see blood everywhere. You see all these holes? Those are where alveoli were, and the blood inside of them just literally exploded out. Now you see this here, all these little white flakes? That's what's left over from, this would have been completely coated with white, basically, like the other lung I just showed you, the big one. But this wasn't big enough to burn off completely. So let's come down here where there's a lot of blood. I'm going to put a little moisture on there. This is where things change quickly. All right, so now we can easily see the different textures here and colors. All right, let me turn the light up just a smidge. All right, this is all blood. That's blood. Now, it's hardened up, obviously, but blood has this rehydration that happens almost instantly. Let's see if I scratch this a little bit. Because what I would do is I would drill down inside here. I'm just going to dig in here. See it? Look at the blood come out. You see that? That's blood. Now, what I normally do is I drill down inside, but that is absolutely blood. When I turn the lights down, you're going to see it much better. That is blood, my friends. Now, that's the surface. I wouldn't use that. I would not use that. What I would do is find one that's halfway down, like inside one of these holes here, and drill deeper, and then get a bunch of goop coming out of there, which is nothing but blood. If somebody could tell me that that's not effective, I would like to know why. I don't. They say, well, you scrape it from the surface. Obviously, it's no good. I agree, absolutely, no question about that. But if you drill into something, which is what I do, I don't see how you could dismiss it. You know, I got to be careful. You got to use the glove and the mask and all that stuff. But it comes out so dense. It's just raw blood, basically. Basically, it's raw blood. And that's what they said, excellent quality. When I had my other DNA tests done, I had 3 of them done. 2 of them were excellent quality. One wasn't so good because it was completely transitioned into mud rock. The other ones were basically just almost like blood. Well, one of them was the lung. This lung right here, hold on. This lung right here. What I got out of this, and what I can still get out of this, is raw red blood. I drill in so I don't get the surface. I showed this the other day. I just scratched this spot right here, and it's just raw red blood. It's still, I mean, it's inside here. It's just saturated in here. It's inside there. This is, the pleura and fascia is what protected all of the contents of. Primarily, blood was the preservative. I know it sounds crazy, but that's just a fact. The blood was the best preserved. I mean, I have stuff here that you don't even know it's. I put that on a plate. A guy would try to cut it. Look at this. You put a little water on these things. Even when I've done this 100 times to this rock. And it just keeps coming back to, and you can feel it. It feels almost slippery, like the blood is kind of oozing out of there. I tell you, I would eat that. I would have no problem with that whatsoever. But again, we need to look at this stuff with a whole new critical eye. And you know, it's just been a very long time to just dismiss this. And the kids are learning stuff that's just not right. It's not true. And anyway, I'm going to leave it at that for today. But as I showed you all my little samples here. Oh, I didn't show you this one. Look at this. This is the biggest, well, I don't know if it's the biggest, but it is a monster. And that was a lung. That was a lung just like this. Came through space, everything smelted off and left only the iron. And you can see right there, watch this. Well, I don't know if you can or not. Let me bring the, whoops. No, I hope we can see some of that stuff. But that's a lung. And right down in that little spot right here. You see that? That's a blood vessel right there. They could actually drill into that and get, I'm sure they could find DNA in these things. I mean, they're just saturated with blood. I've had people hit them open, and the blood literally was wet, and he put his finger in it, and it came out solid red blood. We've been misled. You can't get blood out of a rock. You can't get a rock without blood, as far as I'm concerned. Okay, I have or I will be talking a lot about transition metals and how they are in the blood. And they are the things that move molecules through your body. All right? You see all these little charges, plus 2 and 3 and 4 and 5 and 6 and so forth, 7, and they're different metals. These are all metals. And primarily they're in this blue range here. It's called the transition metal area. Iron, Fe, is the most, you know, that one does the most in your body. It carries oxygen, and it goes through basically 3 states of oxygenation. There's a transitioning state, but there's a FeO2 and FeO2O2 and FeO2O3, 2 and 3 oxygens. But then there's a transition between the two, which is an enzymatic exchange to bring the oxygen transition. Now, how does this all happen? This is where I lose people, but I don't care. If you want to learn, you learn. You don't, that's up to you. These are the core. And all around it, these are what they call ligands. And they form in aqueous solutions, which is watery, serum in your body, blood and so forth. And the metal ions attach to these, what they call ligands, by these little charges. They're just like little magnets holding them. And if somebody else comes along with a different type of magnet, wants it, it goes away. It's just as simple as that. It's very, very simple. And they band away from each other in all these different polarities in the blood primarily, because I'm going to show you, I can prove what I'm saying. All of this is push and shove of polarities. One wants it more than the other. It pushes, it shoves it, and so forth. And then they form these little layers all over the place according to these. And you saw them flocculated in those metal meteorites, I believe, or you will. Let me show you what I'm talking about right now, is how these turn into these. All right, in somewhere where this was in a, I believe this was heart muscle. That's my guess right here. Because in the heart is, not only is the heart full of blood, it's saturated with blood around it because there's a lot of heart pumping going on. Now, you see how these extremely red bands and the black between it, that's what I normally associate. Boy, that's shiny, huh? Knock your socks off. That's what I usually see in iron banding. However, there is some other ones that are down here that are not, they're not just red and black. There's some other metals in it, I think. It sure looks a lot of red and black, but the red is just pronounced. Red is very distinct, and it creates membrane, like little layers around it. I'm sure this is muscle, and these are layers of connective tissue, primarily fed with a ton of blood. That's what my take is now. So it may not have anything to do with iron banding, but this is the iron banding. That, there is no doubt about that, and I have it here. But it's always, in my stuff, it's just black and red. This looks like a bunch of other stuff, but I think it's probably, well, it's probably some kind of tendinous, not tendon, but connective tissue. And this is how abrupt a transition can be between tendon and the glue, literally glue, that glues that strap. And in that strap, there's a ton of fibers, because that's what a tendon does. Now, I have one here in selenite. Hold on. All right, they can solidify, and this one looks like granite or something, they call it. But I'm telling you, that is a tendon enthesis. I'm sorry, this is the abrupt transition. And that's the glue, and then the muscle would go from there. Here's what it is right here. Same thing. But this time it turned into selenite. You see that? And from here, this is the glue. It just stops as straight as a pancake. And then away goes the muscle. This side is the tendon. And again, selenite. What conditions it was in, where it was found, I don't know. Becky Dorius, I believe, was the person that sent this to me. And that's tendon. And this one, I have another one somewhere around here that is actual muscle, and it's all curved and it has all the layers of muscle on it. But this has the actual tendon in it, you can see, if you know what to look for, and that's the abrupt transition. And it's just glued, just like that one's glued. No difference, except one turned into granite and one turned into selenite. This had to be a selenite. I got to look into the conditions of where they find it, but something percolated through here really serious, and whether it was acid or salts or whatnot, but it left just barely the fine fibers of the connective tissue, and everything else was filled in with selenite. Okay, really quickly, this is an iron meteorite because it was, in my opinion, a heart. This is a stony meteorite because it was a finger. That's a fingertip. And it doesn't have enough blood to turn into a ball of metal. However, it had enough blood here. The red blood, because that's the stuff that's really fluid, exploded. It was so hot that this whole side exploded off of this fingertip. I drilled a hole deep inside there to pull some stuff out, but nobody will do the test on it. I drilled deep in here to get some stuff out of here, and nobody will do the test on that. These are both fingertips. Take your time and look at them. They're identical. You see up here? You see that little nubbin sticking off there? Same thing there. You see that right there? That's the vein side. Vein, vein, vein. See that? That's a vein, and that's a vein. That one's cooked a little bit, but it's hard to see. But it's there. That's the vein. That's the vein. They clamp off. They don't blow out. The arteries blow right out. You see that? The artery at the end. There's always artery. And there's vein, vein, and vein. That's the terminus of the blood that comes down and then it comes back. This is identical, only it burnt off its flesh. This just got flattened. This is from the earth. This was not through space. this came through space, cooked everything up, and exploded that side off. This just leaked. You see this? And it even has that. You see that little spot there? Same thing here. It's identical. Has the hook. You really can't tell any difference, except the size, and that this one's cooked. And here's where the tendon's attached at the bottom. See that absolute circle there? Locked right in there. You see, there's the gouge where it held. And then there's another one here and another one here. That one got exploded off. All right, so that's a meteorite. It's just that it's not iron, because it was primarily the end of a fingertip. Well, totally the end of a fingertip. I have another one over here, right here. This is a bony one. That was a bone. And that I can see in a microscope. No question whatsoever that was a bone. You see that? That is iron. It's from the marrow, which is saturated with blood. You see that? That's iron. That shouldn't be doing that. The only way it can do that, it's got so hot, so quick, but it was fluffy. It didn't burn up really like a big chunk of metal, but there was just solid red marrow in the center, so that took on, boiled. The rest didn't burn or boil or do anything, but I can see it, no question whatsoever, in a microscope. It is bone. So there's bony and stony meteorites. But stony just means it's still biology, but it's turned into stone. All of this stuff is stone. All of these bones are stone now. It's just what happens. But in space, they keep the blood inside of them. They're just saturated with red blood, as you can see. And so was mine. I don't know if I showed you in a microscope. I think I did. Saturated with blood. So that's what everything's going. That's what it's all about. We just missed it. We just missed it.